Hey guys, welcome. This is a video for AP Calc, and the focus of this one is in the conversation of what is an antiderivative, what is an integral, and we want to connect the idea of approximating the area under the curve or approximating areas to the concept of antiderivative or to definite integral. There's some information and some notation that this video is also going to cover as well. So to keep it short, or to keep it as short as I can, I want to dive right into it. I'm using example 5.1 and kind of a couple more of these properties here to give you an idea that will eventually lead towards a calculus definition for area. Write in sigma notation and evaluate the sum of terms 3 to the I for I equals 1, 2, 3, 4, 5. Well, in that situation, we'll bring up the document camera. Let's see, we have the information of 3 to the I, but I is going to be able to change from 1 to 2 to 3 to 4 to 5. And later on, like it could go on for forever, but we only have 5 things that we have to identify right now. So that would be 3 to the first, because I becomes a 1, plus 3 squared, plus 3 to the third, plus 3 to the fourth, plus 3 to the fifth. Because it's an exponential sequence where r is bigger than 1, this is going to increase at an enormous rate. We can evaluate some of these terms by hand, right? This is 3 plus 9 plus 27 plus 81. Do you know what 3 to the fifth is? I'm going to take a stab at it and think it's 343. 243. And, evaluate it directly. Hey, Siri, what's 3 plus 27 plus 81? Then for what we could do if we calculated it by hand. But what if it gets to 5, 6, 7, I becomes larger numbers, and you want to continue adding up all of these by hand? No, there has to be an easier way. So we're going to use this notation. That's the Greek letter S. We say sigma. So it is this capital letter. We use index values. We say we're going to start with I equals 1 because that's the number or number that we're starting with. And we're going to stop at 5. So we put a 5 in the top above. This notation right here sets up our boundaries. And then we go 3 to the I. This is doing what we did right here. Boom, bring that in, 363. I'm going to see if Desmos can do this. This is kind of a cold, drawn-out thing. Does Desmos want to do this summation notation? We might need to find some other resources online. Spreadsheets would do this. Let me see if I can set it up, though. Here we go. Sum. Yes. It doesn't let it. Can I use I instead? I can use an I. I can go 1 to 5. Let me make this a little bit bigger for you. Okay, and then a little bigger from there, too. Then I want to go in the argument of the summation 3 to the I. It does. I just typed SUM in Desmos and it can calculate a definite or a partial sum. That's some information for you for a later class. We get the partial sum 3 to the I goes from 1 to 5. The answer is 363. I'm going to continue showing some other options. Stick around for some other videos. Trying to keep these short and choppy so you can pick and choose whichever ones you want to use. Thanks. Bye.